Welcome to lesson 65. Today we get to play around with pie. I wish I had one to throw in your face as a joke. As a joke. Right? It'd be cream filled. It would be delicious as you licked it off your face. No, we're talking about the mathematical pie here today and its relationship to circumference. The slide you're looking at, or at the moment, is probably pretty familiar to you. You've seen it a number of times as we've gone through this idea. And as we look at it, we can talk about it, right? Which color represents circumference? Circumference, of course, is the distance around a circle. And so you're quickly saying, green, I knew that. Good. What color represents the radius? The radius, of course, is the distance from the edge of the circle to the midpoint of the circle. And so you're screaming, yellow. Maybe not out loud, but in your head. And which color represents the diameter then? So the distance across the circle through the midpoint. And, well, there's only one color left, so of course you're saying red by this time. All right, this concept is review, and we want to move on. We've actually used these in a number of different ways. Learning them, we did an activity where we took circular objects and we used string and tape measures to discover what pi was. And in the end, we came away with understanding that circumference of a circle has a relationship to pi by multiplying pi by its d for diameter. And from there, we can also pull away a second equation where circumference is pi times 2 radius, because diameter is equal to 2 radius. And so as we're substituting those different things in, we're able to solve a multitude of problems. For instance, we have the radius of a circle is 10 centimeters. What is the circumference? Okay. All right, so circumference equals pi times diameter. That's our initial equation. However, as we're looking at this, we're realizing this says radius. It doesn't say diameter. What am I going to do? Well, I'll tell you what you're going to do. You're going to remember that diameter is actually 2 radiuses. So we're going to rewrite this as pi equals 2. Circumference equals 2 times pi times the radius. And the radius happens to be 10 here. And usually you put the 2 first, because the multiplication that you end up doing has a tendency to be a little bit easier, rather than doubling the radius and then multiplying. Right? Now, you can argue with me, you can do it a different way, but that's why they write it this way. They just kind of feel it's a little bit easier. Right? Okay, with that in mind, now we need to look at the idea of pi. Right? Pi, as you've learned to know it, is 3.14, which is a great estimate of that number. And some people would say, well, 3.14 is not a very good number to use. It would be better to use 22/7, which if you were to try and divide that out, you would get 3.14, and then the decimals would continue on. Right? And so understanding this is the reality that pi, as we usually think about it, that 3.14 is kind of a rounded number. But it gets us very, very close to the actual answer. However, today you're going to be working with both. You're going to be working with this when they tell you to work with this, and they're going to be telling you to work with 22/7 when they tell you to work with 22/7. Okay? Let's go ahead and do this with our traditional 3.14 as pi. So 2 times 3.14 times 10. That's not a decimal, that's a 10 times. I'll put a whatever that thing is as multiply. So 2 times 3.14 is 6.28, and then we're going to multiply by 10, which moves the decimal point 1 space to the right, which is going to give us 62.8, and the circumference. Right? I believe we're dealing with centimeters here, and we leave it like that, centimeters. Excellent day. Now it's your turn. Show me you remember how to do circumference. And as you work with circumference, I've given you some special directions how to solve each of them, what to use for pi. And don't let this one confuse you. It says leave pi as pi. Don't change it. make it pie. Right? We'll talk about these more in class. That's it for lesson 65.